All right. So welcome everybody to our LeetCode Workshop. And I'm your presenter today. My name is John, and I'm presenting on behalf of the Langara Computer Science Club. So what is LeetCode? LeetCode is a website that's used by many programmers to practice solving problems and algorithms. And it supports many languages and skill levels, commonly used to prepare for technical interviews, especially for jobs, and can be used to practice problem solving if desired. So in order to use LeetCode, you'd first go to LeetCode.com, log in using the login registration page, and afterwards you'll be able to access all the problems on LeetCode and solve them. So on the left side of the problem page, there's usually a description, and there's tabs to go see the editorial solutions and your own submissions. So if you ever feel like you lost a LeetCode submission, go look through the submissions, see if you can find the one that you're looking for, and your code from previous submissions should be there. On the right side, there's a text editor. That text editor seems to be based off something like VS Code. And you can also change the language, create solutions, and there's also an option for debugging, running, and submitting your code on the bottom right. So just so we're educated, here's some alternatives to LeetCode. We have HackerRank, AlgoExpert, which I have used, CodeWars, Editbit, InterviewBit, Euler Project. These ones are relatively popular, but LeetCode still seems to be the most popular algorithm solving website that I'm aware of. And here's a large list of languages that are currently supported on LeetCode. So don't be too worried about working on learning a specific language unless you're looking to learn that specific language for a job interview or for a job. Whatever language you have probably works here. They're always constantly updating, adding more languages. Not too much to worry about. So what do you need to actually start learning LeetCode? So ideally you'd have proficiency in one of the languages shown in the previous slides, basic understanding of algorithms, including how to solve them, and a computer. It's nice to have a computer to solve algorithms. And for those of you who are studying at Langara, CPSC 1150 is highly recommended, as this course introduces you to programming, program design, how to get started on actually writing code. And CPSC 1160 will be useful because it introduces you to algorithm solving. So here are some data structures. I'm sorry because the font's kind of small for you people in person. But for beginners, arrays and hash tables or dictionaries, it's probably good enough to solve a lot of easy to medium problems. For people looking to get farther in, you probably want to learn about stacks, queues, frontiers, linked lists, and trees, especially binary search trees. There's a lot of problems that involve nodes, which are used in both linked lists and trees, so those would be pretty helpful to know. Frontiers is just kind of it's just a type of data structure that's used as like an overarching theme for like queues and stacks. So not too much to worry about in terms of getting into the nitty-gritty of it. And advanced data structures, you have matrices, graphs, disjoint sets, heaps, and k-dimensional trees. A lot of these I don't even know how to use very well, to be completely honest with you. But there are some more difficult problems, and these are especially useful when it comes to learning how to optimize your algorithms. But a lot of optimizations, if they ask you an interview, hash tables, dictionaries, there's your cheat code. So does everyone here know what I mean when I say an algorithmic paradigm? So an algorithmic paradigm is just kind of like a concept that can be introduced through code. Like the example would be like the black box paradigm. That's a pretty good and important one to learn. You have a desired input, a desired output, and there's a black box. And what are you going to do with the black box? Well, you got to make that black box yourself. How do you get that input into that desired output? You have other paradigms like brute forcing, just solving the method or algorithm by any means. Divide and conquer, which is subproblems, which would mean if you have a larger overarching problem, such as you're trying to convert one thing to another, that could be considered as a subproblem of a larger problem. You also have dynamic programming, which is top-down, bottom-up. This should be taught to you in CPSC 1150. Yeah, 1150 it should be taught to you. And this is just the idea of having your program be structured in terms of tiers, just so you can have a better understanding of where each portion of the code is and how each function interacts with each other. Some more intermediate paradigms would be stuff like backtracking, recursion, prune and search, and memoization. And more advanced stuff would be greedy versus thrifty optimizations. So like depth versus breadth. Are you going to optimize to go deep, or are you going to optimize to take the overarching theme first? Eager versus lazy. When it comes to like machine learning, for example, how eager is your algorithm to learn a piece of data? Or is it more lazy, or should I say more cautious when it comes to each piece of data? And this could be especially important for analyzing data sets with outliers. Branch and bound. This is like optimization via subproblems. Optimization via subproblems could be useful because you want to make sure that your program always runs at its optimal speed. And especially when it comes to doing program like algorithms on LeetCode, a lot of your solutions probably going to be 20, 30 lines, and you want to make the most out of what code that you're actually submitting. These two paradigms, divide and conquer and dynamic programming, these are probably some of the most important ones. Divide and conquer is the concept where you break down your large problems into smaller ones. And dynamic program is you solve a class of problems through overlapping problems. So if you've already made a conversion from binary to integer before, you could reuse that in another problem. Like if you made it an add binary, you could use that in subtract binary. So what happens if I'm lost trying to solve a problem? You want to evaluate the situation. Am I currently equipped to solve this class of problem? What methodologies must I be familiar with? What data structures does this problem require? Familiarity with especially, and how can I segment this problem into smaller pieces? Are there helper functions that I can create to solve the larger problem? Helper functions is something that I think is really important for people to learn because it introduces the idea of offloading a big piece of a problem. So you could treat this like the management of a company, and they're going to divide it up into more of like, you could say the working people of the company, and they're the ones managing what's happening. So you could treat your main program, so like let's say you have a program in Java, you have a main, that would be your management. And then you can create sub-functions to help solve that larger problem. Can I create a solution using words or diagrams that I can easily translate into code? So let's go back to the example of binary. So for you guys here, raise your hand if you know how to convert binary to decimal. That's about half, about what I expected. But if you don't understand how to approach a problem converting binary to decimal, then it's more like, okay, I can't even describe how I would do this thing without code. So how am I going to do it with code? You can't instruct a machine to do something you don't understand what it's doing, right? So I think that's one of the most important concepts when you're looking at algorithms. And my biggest tip would probably be to just be open to learning, especially. There's a lot of different algorithms that you'll see, and especially ones you might get in job interviews where you're gonna have to learn on the fly. You might have a concept that you're not too familiar with or you've never seen before. So how are you going to approach that challenge? A lot of algorithm solving is a challenge, and that's okay. That's part of what algorithm solving is. So before I go into more examples of algorithm solving, does anyone here in Discord have any questions? All right, I'm going to take that as there are not many questions. So let's continue with the PowerPoint. Today's menu, snakes. The reason I say snakes is because I'm going to be showing a lot of the problems in Python, which is my preferred language of choice. I know at Langara especially, you guys should be very familiar with Java and C++. So if that's like the language you prefer, be my guest to use that language. Around now is, I think, a great time to open up LeetCode if you guys have it. Open up an IDE of some sort if you prefer. But it's also cool to just relax if that's what you're more into, just here to learn the theory. And if you have questions about the given problem, feel free to ask. I think we can open this up in Safari. All right, so you guys should be able to see my screen again. So when you go into LeetCode, there will be a sign-in button here. Just want to make sure you log in. Then you go to the problems page. So the first problem we're going to be looking at is add binary. And let's take a look at this problem together. So given two binary strings, A and B, return their sum as a binary string. So you have, for example 1, your first input string, your first argument is 11. And your second argument is 1, and your output is 100. Well, if we break that down to decimal, your first input string has a value of 3. Your second input string has a value of 1. So it gives you an output of 4. So if you guys remember how to do binary addition, this is the correct output. So how do I get from this plus this to become this? What do I need to make inside of here? And it's the same thing when it comes to example 2.
You
You could parse into an integer, correct?
and then reverse it,
Yep.
and then start condition with this root number. Like we can extract the last two numbers.
Yes.
And then apply conditions if both numbers are 0, 0 or 0, 1 or 1, 1.
Yep. So that would be just having the strings. So the two methods that he mentioned there are, one of them is changing the binary into integer values, and then you add those integer values up, and then you return that converted integer back into binary. And then the second one you said is when you do the method of bit computation.
Yeah, that can also.
Yes, and that's the one where you keep those as strings and you compare the values within the strings and you create your own arithmetic And by doing that, you have created a program that does not need to convert into decimal systems in order to add or subtract. So this problem takes in two parameters, returns a string, asking us to add two positive binary numbers. So here is that first method, the conversion method. You can see the code here in Python is extremely small. So what we're doing here is we're converting the base 2 strings into base 10 integers. If you guys remember how conversion works, that's cool. If you don't, I'll break it down a little more in the next slide. Then we're going to add the integers, and we're going to convert the result back into a base 2 string and return. So here's what it would look like to have some helper functions. You have the binary to integer function, where we have a decimal, and we're going to iterate through the string. And we're going to basically add what each value is at a given point within that string. And then we will return the decimal value out of that helper function. The integer to binary function is basically saying if the integer is 0, we return a 0 as a string. Otherwise, we're going to build a string. And while that integer number is greater than 0, we're going to be adding actual strings into it. So it's like binary. And then we're going to get the remainder, and we're going to add whatever we had before. And then we're going to divide it by 2 and form whatever number we have there, and we're going to return the binary. So then the result is you convert string A to binary, string B to binary, and then you convert it back. And that's the result for this method. So there are some problems with this method. As you guys know, this method, we have to convert between different types. So I'm assuming that a lot of people here are familiar with your different data types in computer science. How many bits does an integer store? An integer, in general, stores about 32.
If it's 32-bit compiler, I think integer is 4 bytes. And if it is 64 bits compiler, I think it is 8 bytes. And 8 bytes are 64 bits.
So usually an integer is 32 bits for most programming languages. For a long integer, it would be 64, and for a short, it would be 16. But how long is a string? Because a string is an array of characters. At its core, a string can be infinitely long. So what happens if we start dealing with a number that's like 1110, 11111, and it's just really long? And then we try to convert that into an integer. How would that fit? It just wouldn't, which that's probably the biggest problem with this. Fortunately for us, LeetCode doesn't involve numbers that long in the test case. But in the case where that does happen, and I know a lot of people that would be attending this workshop right now would be interested in doing things like co-op. This would be a major consideration, because what if your future employer says consider all possible cases? That becomes a big concern. The time complexity is also not great due to the conversions, but it's not terrible either. It's O of n, so it's not the end of the world. But in order to resolve this, we can do it approaching the bit computation method. This is my preferred method. This method has no limit to how long your strings can be. However, it is a little bit more complex. We have to make sure the strings are the same length, or we have to add a conditional to make sure that the iterator goes for and actually make sure it's that, sorry, I'm losing my words here, but Basically, the iterator has to be able to keep track of the strings. And it has to compensate for both lengths, because a lot of the times when you're adding binary, you'll have different lengths of numbers. You also have to make sure you understand the addition of binary a lot better here. So step 1, we're setting the strings to be the same length. Step 2, we're iterating through the strings backwards. Why are we iterating through it backwards? Because if we iterate it from left to right, that's not the way addition works. You're going to have some really weird numbers. Where are you going to put your carry numbers, especially? So you have to iterate from right to left, which is backwards in a string. And using a carry variable, we'll calculate the addition of each binary section, and we can append that answer to the array. And then afterwards, we're going to reverse the array and join it into a string to return. Because the direction that we appended the values would be in reverse. Since appending things to an array goes to the right side, but ideally we'd want to append it to the left side. But it costs a little bit less to just reverse the string at the end rather than keep trying to append things to the front, because with the way that arrays are declared in most programming languages, it does not like it very much when you try to put something in the front. So, which method of these is better? Arguably speaking, it's a lot easier to understand the first method. Who found it easier to understand the first method over the second one? Most people. But just by nature of this problem, the second method, the complexity improvements, and the different test cases that you could have that could pass through the second method, not the first, that's a lot. And that goes to show a lot into what you can actually do by following it's set like a rule set, especially when you're dealing with something that has as many possibilities as a string versus an integer. And we can't ignore that, especially when it comes to doing large computations. This problem can also be solved via bit manipulation for maximum optimization. And it also gives you the most options for when it comes to solving it by length and still solving at a more optimized rate. And feel free to dive to that one on your own. It's pretty interesting to see how they explain bit manipulation on the LeetCode editorial, but unfortunately, I don't feel qualified enough to talk about it. And here are also just the test cases here. So if you look on these images, the left image is the conversion, the right image is the bit computation. If you look at the runtime differences, it's pretty massive. The runtime difference, this runs like almost twice as fast when you're doing it with bit computation versus converting to an integer and back to a string. The memory usage is better when you're just doing the conversions because you're not storing as many values, but it's not really that important. A lot of the times when you're dealing with data sets like these, you're trying to optimize more for speed rather than for memory usage. So that is something to keep in mind. We have another problem I would like to look at, which is the palindrome number problem. So I'm going to leave you guys to take a look at this one and take a crack at it. I'm sure there are a lot of people here that have probably done this problem. Maybe take a good, I would say, 5 to 10 minutes to give it your best shot. I'm going to remove this because that's one of the solutions later. Feel free to discuss it in the Discord chat. Feel free to discuss it in person as well with the people beside you.
question.
Sorry?
So this is more of my midterm preparation question for 11.
Yep. This one should be an 1150 question. You familiar with this one?
Went back to memory from my fried brain. What did I do? I believe I took the remainder. I took the remainder of it to get the last digit of one in, and then just basically built a new string and then turned that string into an integer and then just converted it to variables.
I just want to at least do it. But because you're familiar with this, I'm going to challenge you. Is there another way to do it?
Is there another way to do it?
Yeah.
Give me a hint. Is it a mathematical solution or is it a string solution?
This one would be a more mathematical one for sure.
Okay, well, it's like a math. So.
I just take the number from the half and add it from the last first digit and the last digit. Comparing the sums, it's equal in the end. So I don't know.
Now the question I have for you is how would you compare the first and the last digit? Because this is an integer, not a string. How would you, the last digit is easy because we know we can use the modulo operator to get the remainder by 10. What's the easiest way for you to compare the first digit? I don't know, I'm guessing it'll probably be done around like 540, 545. I don't want to run through everyone's attention span because people have gone through a lot of class today already.
You guys have like videos or anything?
Just wait, this Wednesday?
Today's Wednesday.
Yes, Monday. I think this week and next week too.
Oh God.
My class is not that cool. Shrine. People just crowding for exams.
My plans would be accurate.
I think the one way to do it would be to just keep on dividing it with the multiples of. They're trying with the multiples of 10 and just read a point when they're doing it. And the quotient is less than 1. So in the when the quotient becomes less than 1, it means that's the I should say last place, like if we take because first of all divide by 10.
That could be a way to do it, but the only thing I have to say about that is that's costly.
Yeah, for sure, that's possibly better.
What if adding all these digits together?
You can't add, and we don't. Unless you convert them to
1, 2, 1 is 4. Take the 1 from the other one, nothing together.
But what if it was 1, 1, 2?
Because it was a solution.
I'll just give you guys hesitant.
Yeah, it was a math.
Well, let's say 1, 2, 3, 2, 1. Mod 10 equals to 1.
So is that a dot you put in there?
Sorry?
Is that 1, 2, 3 dots?
No, that's just 1, 2, 3, 2, 1. That's what it was. 2 mod 10 equals to 2. So what if I added these up in a way where it would be like 21, for example? Or what if I added up in a way so that it would show us 12 and I could compare that to 1, 2, 3? Or if the 3 got shifted, how can I compare these and account for this 3?
1, 2, 3, 2, 1. Mod 10 equals 1. 1, 2, 3, 2, 1, 10 equals 2. Okay, well, you're going to put 2.
Well, that's how you can get this number in the right. And let's say we did it again, we get the 3.
Yeah.
but how do we account for the 3 now? What if this was an even length instead of an odd length?
So is this thing in the last sentence you're reversing the order, and then you're adding them before you finish the loop? What you're trying to do?
Well, that's one. Well, it's like you're adding them through the loop. So the way that you would do it would be you'd have like a while loop, and you'd have like some conditional here, right?
Yeah.
And then here you would have like some type of variable, and you're gonna add the mod of whatever was here earlier. So like, let's say x is your integer, right? So x mod 10.
Yeah. You got the last digit.
But then how do you make sure that this actually goes through and is the right size, right? So you might want to actually just make this bar equals to x mod 10 plus bar times 10.
Right.
Right? And that's how you can make sure you're retaining the old value here. If it's a 0, it doesn't add anything, so you don't have to worry about that.
Yeah.
If it's a 1 and your x mod 10 was 2, then it becomes 12. Right?
Now you're typing a plug.
Don't worry, I'll be going through the solution in just a moment.
That just looks awfully familiar.
Whatever. They have that. Let me just double check.
All right. So I'm hoping you guys have had enough time to discuss or think about the problem. So this is another problem that would be considered relatively easy. This problem is asking us to determine whether or not an input number is a palindrome. Our parameters is integer x, and it returns Boolean. So, string conversion. I'm pretty sure everybody at some point was just like, what if I converted that number into a string? Wouldn't that be really easy? Yes. That's why I love giving this problem to all of my friends who are new to programming, because it makes them think outside of the box. Sometimes the easiest solution is to change its data type. And while I'm going to be honest, it might not be the most efficient solution, it's still a good solution because it's easy to explain, it's easy to learn, and you can always optimize it later. So the first thing you're going to do is you're going to typecast that integer into a string. So if you look where my cursor is around here, that's how you typecast in Python. You're just getting that x value, and we're going to set it to x string equals the string of whatever x was. Then we're going to initiate 2 pointers. One on the left, your 0 index. One at the right, that's your last index, which is your length minus 1. While your pointers, so basically you're going to be like, while your left pointer is less than your right pointer. So while they have not met or crossed paths, you're going to do a check. Is that character at your left pointer equal to the character at your right pointer? If they're not equal, you want to return false because it's not a palindrome. Otherwise, you're going to iterate your pointer. Your left pointer goes right and your right pointer goes left. After a certain point, they'll cross. Once you know they've crossed or they've met in the middle, that's when you know it is a palindrome. So you can return true outside of the while loop. Obviously, this is already pretty good. If you want another way to think about how you can rock with,
So what we can do is we can reverse the number and check if this is equal to what number.
Yeah, you could do that too. You can also just reverse the string and then check that. The thing is, reversing a string is a little bit costly, but once again, that's another even easier solution to understand.
If we parse the number into string and then again into an integer, it also consumes time. What if we just look on the number?
Sorry?
Converting the number to string and then converting back to integer.
I guess you could,
So we can just reverse the number.
but there's not, I don't think there's really much reason to convert it back to an integer. Once it's in a string, it's probably easier to just work with it in a string. And then you're going to run into the error of if you have a negative number and then you reverse it, and then you convert that negative number back into an integer, it's going to throw an error because your minus is on the right. But you can just convert it into a string, get a new value, use that old value to get the reverse of it, and then compare those and return based on that.
Just reverse the number and then
Yep. Another way to do this same method, a little bit different, is just use a for loop. It's a little bit more complicated. Instead of allocating a whole extra pointer, you just do a for loop. I don't know if I'd recommend doing it this way, to be honest, because it makes your code a lot more difficult to read. It improves your runtime just a little bit, shortens your code just a little bit. But I don't think I would recommend this one. For those of you who can actually see what's going on in that for loop and seeing how I'm getting into that variable, it's a little bit messy. So here are some things to consider with this method. This method does convert the integer to a string. Since it only does this once, it's not an extremely costly operation, but it does allocate a decent chunk of memory. The other thing is a lot of people, especially interviewers, will present you with a clause to not convert it out of an integer into a string. So they might tell you, you cannot use strings, you cannot use arrays. So when you're presented with this problem, how are you going to approach it? So overall, converting the string in this problem does not present very many problems, but it is nice to have that option. When you don't, you can use integer manipulation. So I'm going to explain the steps here, and I'm not going to show the code, and I'm going to see if you guys are able to think of how you would code this out. So step one is you have to consider your special cases. So how are you going to deal with a negative integer or an integer that has a tail end 0? The only integer that has a tail end 0 that could be a palindrome is 0.
I'm here.
Go away, Siri.
Okay.
But yeah, basically tail end 0, you've always got to consider that. And basically create a conditional to ensure that the cases we're working with don't meet these. So if you have a negative, or if you have a number that's divisible by 10 that's not 0, we're going to return false at the start. Then we're going to create a new integer for that back half of the number. After we've created that new integer, we're going to parse the numbers to that back half variable from the front half. So for you two at the front, you guys were watching me try to demonstrate how to get the number at the back, put it into a new variable, right? And after you get that new number, you divide your old one by 10, so then you can get the next one and do it again. And basically your while condition would be while your old number is greater than the back half one, then you're going to keep doing that. And then you want to return if x, which is your old number, equals that back half, or that back half divided by 10. And by having that or statement, you're dealing with cases that are okay for both odd and even numbers of length within the integer, which is pretty important. So for those of you who actually are pretty interested in learning how to code that, I'll leave you guys 2 minutes to think about how you want to code this, feel free to discuss as well.
Sorry, will you turn the slides in after?
Yes, I will be moving the slide after. You don't have to actually code it. Just feel free to think about how you do this. Just because I want to get your brain to think about how are you going to convert this set of instructions into code.
I think next time let's plan this for like 9 in the morning.
It's okay.
I'm just kidding.
It's probably been a long day.
It's a normal thing. And actually, I did, now that I was looking at my solution, I did in fact did what you I mentioned of just model those into expensive by 10 or just get I don't know.
Yeah.
So, I just, one of those things that you do, and you're like, hey, it worked, and you move to the next problem.
Yeah. It's just good to know how to continuously understand how the process of thinking works. So what you guys will learn a lot through solving more algorithms is that it's not always too important to have the tools, but to know how to use the tools is more important. You can have that programming language and a good depth of it, but if you don't know what goal you're trying to accomplish, what is that programming language going to give you? So there's, I'd say, different types of people that come to programming. Some people are really good at problem solving, especially for those people that are more mathematically inclined. A lot of people like those would be very good at figuring out a solution. But some of those people would be like, okay, how do I convert my solution that I have in my brain into code? And sometimes that's difficult. That's a lot like me. Versus you have some other people who would struggle more with actually getting the solution. Whereas once they have the solution words, like, oh, this makes sense. I can convert this into code pretty easily. But getting that solution can sometimes be a little bit difficult because it's not always the most straightforward process. Sometimes you have to break down the problem and be like, how am I going to solve each portion of it? Here's the solution I have in Python. I'll skip the slide. Basically, the conditionals at the top. Basically, if x is negative, so less than 0, or if x is not 0, and x mod 10, so the remainder of x divided by 10 is equal to 0, then we're going to return false. And that's how we've dealt with the special cases here. Then we're going to initialize our back half variable as an integer. And we're going to set its value to 0. So while x is still greater than the back half, we're going to set back half to that back half times 10. And then we're going to add x mod 10. And then we'll do some integer division where we're going to divide x by 10, but keep it as an integer. So we're going to truncate the end with floor division, which they have in Python. And then you're just going to return the conditional x equals to the back half, or x equals to the back half floor division of 10. So that would just be dividing it by 10, truncating the end. And yes, you can return that statement. I think it might have been a little bit easier in hindsight if I had just set that to a new variable and returned that. But you can just return a conditional like this and it'll return a Boolean that's true or false. Any questions? All right, since we have a little bit of time, I want to show you guys this problem. This one is a hard problem on LeetCode, but I don't want you guys to go into it with that process of thinking. I want you guys to think of how you could approach this problem with some words. So yes, I will leave the solution here. So basically, I just realized I did not exit the PowerPoint. So it's basically given a set of integers representing an elevation map. So all of these black values you see would be the value of the array. So at position 1, you have a value of 1. At position 2, you have a value of 0. So that's why there's no black boxes. And you're basically trying to see if it rained top down and all the water washed away in the sides. Like how much water in terms of like puddles in volume could there be? So for example 1, this is what it would look like. How would we get to the point where we can count all of these blue squares? Right, well you could say, I think the easiest way to think of it would be, okay, on the left side and the right side here you can never store anything because there's no way for it to have surrounding barriers to store water. But let's look at 2, for example. We can see that this stores 1 water block, right? So it has pillars on either side. So how would we check for these pillars on either side to see what the maximum is? Or if you look at position 5 here, there's 2 blocks on either side, but it also has a value of 2 because there's more than that it can fill because it's a larger hole. So how would we account for something like that? This is my more optimized solution, but one of the probably the easiest baseline solutions that I could recommend would be to start at a given point. So let's say I wanted to start at position 5 here. So I'm going to go and find the highest value to my left here. That's 2. The highest value to my right, that's 3. So now that we have these values, we can take the minimum of those 2 maximums, and that should be the value of the square. So that's the theory I'm presenting here, right? So let's try that. At position 0, the left max is 0, the right max is 3, so 0. At 1, the left max is 0, the right max is 3, so that would be 0. But in the case of, let's say, position 4, the left max is 2 and the right max is 3, but has a value of 1 because you now have to subtract its own initial value of land to see how much water would actually fit in there. So you could do that by doing a for loop this way and then a for loop that way and then calculating it and doing the whole thing in a for loop. And yes, while that is O of n squared for those of you that understand time complexity, it's not very efficient, but it's a good place to start with a problem like this. Don't forget, this is a hard problem. But now that you understand what this is asking out of you, and now that you have some idea of how you want to approach this, it should be a lot easier to understand what's going on and how to approach a problem like this. This problem, relatively speaking, could probably fit into like one of the easier hards, but just remember, if there's any hard question you want to try, now you know a little bit about this one. So hopefully, if you guys feel ambitious, you can try this problem, have some fun with it. Let's take a look at another problem. So if I wanted to look at let's take a look at removing duplicates from a sorted array. This one should be pretty easy for you guys to understand. So this one is basically saying since it's impossible to change the length of an array in some languages, like Java, like C++, you can't change the length of the arrays. So how would we remove this? You must instead have the result be placed in the first part of the array nums. More formally, if there are k elements after removing duplicates, then the first k elements of num should hold the final result. It does not matter what you leave beyond the first k elements. So this is basically just saying, okay, what is the length of the array going to be after I remove all the duplicates?
Sorry, say that again. What's the length going to be?
Yes, this one
Length's gonna
returns.
be the same, isn't it?
This one returns a length. Well, you're trying to figure out the length of the perspective array, not the actual array.
Okay.
So if you look at
how many values you have there?
yeah, if you look at example 1,
Yeah.
you'd have 1, 2, and then you don't know what the heck this is going to be.
Yeah.
But then that's output of 2 because it would be a length of 2 if you could truncate that array. Because you have 1, 1, 2, which is your input, and then one of these ones is going to go. You're going to move that 2 in its spot, and your output's now 2.
Is the array originally sorted?
Yes.
I'm assuming it is.
Yes.
Wouldn't you just, well, compare k with the next, compare k with the next number over,
Yeah.
remove it.
You could just keep comparing the number to the number in front of it. If it equals the number in front of it, then you remove that current number,
Yeah.
and then you can just move all the empty slots to the back later doing some swaps. That's a pretty easy way to go about it. But I think the most important thing to look from this problem is just to see what the problem expects of you, because even the output is 2. It's basically just saying, okay, your function should return this. And the reason it wants you to return that is because you should have sorted it already. It's not saying use other methods. It's specifically saying in the instructions to sort the array after removing the duplicates and then return that k value. Because if you guys know anything about dictionaries in Python, hash maps in Java, you could store the values pretty easily and then just add up the amount of keys. That would be a pretty simple solution. All right. I don't want to bore you guys for too long because a lot of you guys had long days, so let's finish up here. So I have some takeaways. So there are many ways to solve problems, so don't be scared of trying different ways of approaching a solution. It's a lot easier to approach and break down problems, like especially easier ones. So if you start with easier algorithms, you'll build these skills that you need to solve harder ones. And if you ever feel unequipped to solve a problem, that's okay. Take the time to learn your coding paradigms. Take the time to learn your data structures. And my biggest recommendation is if you have friends or if you want to go in the computer science Discord server, feel free to ask people. I'm sure if you ask people for help, there will be people that are willing to help you solve your problems. So that's pretty much it for today. I didn't want to make this one too long because I know a lot of you guys have midterms to study for. Or you guys probably want to break from your midterms and I don't want to make this lecture too long. So next week is going to be a lot more collaboration. So I'm hoping we get more people in here and we can work on solving algorithms in a group. That would be my ideal scenario. So hope I'll see you guys next week, and thanks for coming.